So this video lesson is all about angle pairs, some special pairs of angles based on things that we've talked about before, and what we call compound figures, which are just figures made up of one or more things that we've seen before, and it can be broken down into smaller pieces to make it easier to deal with. So before, what we had talked about, there are two special angles that we like to reference. We have a straight angle, which is basically a straight line, or a complete 180-degree turn, so that you're facing the other way, and a right angle, which is a quarter turn. So if you're facing north, then you can turn and face either east or west. And so right angles are particularly important because they help us talk about specific shapes like squares and rectangles and right triangles and things like that. And then straight angles being basically a line or a line segment or a ray or something like that, are really important to us too. And in fact, they are so important that we have names for angles that add up to these special types of things. We could imagine that this straight angle that we see in red could actually be made not of just one angle, but two angles to start off with. So our first angle would have been this first turn, and then we turned some more to end up at 180 degrees. Now, if that's the case, those two angles add up to one straight angle. And we can see they add up to one straight angle because one angle plus the other angle makes up the two parts of that straight line. Similarly, we can talk about angles that add up to 90-degree angles. So that if we had these two smaller angles here, this angle that I'm coloring in red, and this angle that I'm coloring in green, together, these two angles add up to 90. And so because straight angles and right angles are special to us, we have names that talk about angles that add up to right and straight angles. And so if two angles add up to 90 degrees to form a right angle, we call them complementary. So go ahead, pause the video, write this definition down that I'm boxing in green, complementary angles, and also this figure right here, so you can see what we're talking about, and then unpause the video when you're ready to talk about it a little bit more. So here, these two angles add up to this one right angle. Angle 1 to the right, and angle 2 together form one right angle. Neither one of those are 90 degrees. In fact, both of them in this case are 45, but they don't have to both be 45. But together they make up this one right angle, and so we call them complementary, angles whose measures add up to 90 degrees, to that right angle. And so we have this equation over here, m angle 1 plus m angle 2 equals 90, and all that really means is that we take the angle measure of angle 1, we take the angle measure of angle 2, we add them together, and we turn them into a 90-degree angle. So if angle 1 were 60 degrees, we could find out then what angle 2 would have to be by taking that 60 away from 90. Angle 2 then would have to be 30 in order for angle 1 plus angle 2 to equal to 90. And so that's the whole idea behind complementary angles. I think it's something you've probably seen before. If not, it's pretty straightforward like that. Now the same thing is true. We have a different name for angles that add up to a 180-degree angle, to a straight angle, and we call them supplementary angles. So go ahead, pause the video. Again, you're going to draw this figure that I'm boxing in red, because that shows the straight angle made up by angle 1 and angle 2, and then write down this definition that's in green, and then unpause the video after you've done that when you're ready to move on. So, as we can see, the red line in that top picture is a straight angle, and angle 1, which I'll color in purple, plus angle 2, which I'll color in green, those two angles add up to one complete straight angle. They add up to that one red line, and so their measures must add up to be 180. Much like that last equation that we saw, this just means that angle 1 plus angle 2 must be 180 degrees. So if angle 1 were 70 degrees, we could find out what angle 2 would have to be, which is just what it would take to get back to 180, and 180 minus 70 is 110. And so that's how we find out what complementary and supplementary angles are. So I'm going to ask you to pause the video here in a second and find the angles that are complementary to a 12-degree angle, a 70-degree angle, and a 40-degree angle. Remember, complementary angles must add up to 90, so what angles do we need to add to each of these so that the total angle measure would be 90 degrees? Go ahead, pause the video, and come back when you're ready to talk about it. So if we already have 12 degrees, and we want to get to 90, well, we can take 12 away from 90, and 90 minus 12 is 78. So the angle that is complementary to 12 degrees is 78 degrees. If we already have 70 degrees and want to make it to 90, well, all we need is to add 20 more, and we'll get to 90 degrees. And the same thing is true for 40. We only need 50 more degrees to get to 90. And so these are the three angles that are complementary to the ones on the left. 12 and 78 are complementary angles because they add up to one right angle. 70 and 20 are complementary angles because they add up to one right angle, and 40 and 50 are. Now let's do the same thing with some angles and find out what the supplementary angles are, which means that they have to add to 180. And so let's go with the angle 70, with the angle 125, and with the angle 8. Go ahead, pause the video. These are all meant to be degree measures, not use. And find out what angles it would take to make 70 turn to 180. What would we have to add to 125 to make 180? And what would we have to add to 8 to make 180? Pause the video and come back when you're ready to move on. So for 70, if we already have 70 degrees, then 180 minus 70 will tell us what we need, and that gives us 110. So even though 20 is the angle that is complementary to 70, to add to 70 to get to 180 degrees to that right angle, we need 110 degrees. To add to 125, we need 55 degrees. And to add to 8, we need 172 degrees. So those are the angles that are supplementary. 70 and 110 are supplementary. They add to 180. 125 and 55 are supplementary. Together they create 180 degree angle. And 8 and 172 are supplementary. They make a 180 degree angle. And so in the original angles twig video lesson, we looked at some beams underneath the bridge. And here we can see a lot of angles going on, a lot of different things crossing each other. But one of the things that we can notice is that if we draw a line through this beam here, and imagine that as a straight line, and this beam here, we can create some angles that are formed by just two intersecting lines. Now we'll have to imagine that this bridge here does not exist. All we're looking at are these red lines. And so we've got a lot of other things going on, but with these two intersecting lines, I'm going to ask you to pause the video and see what you notice about some of these angles. Let's call these angle 1, angle 2, angle 3, and angle 4. So go ahead, pause the video, jot down a few things that you notice. Are there any complementary angles here? Are there any supplementary angles here? What sorts of things happen when it comes to just those four angles? And then come back when you're ready to look at a few of those. Well, the major thing that we can notice is that angle 1 and angle 2 actually add up to form this straight line that I'm outlining in blue there. And so angle 1 and angle 2 are actually supplementary angles. They create that right angle. The same thing is true for angle 3 and angle 4. They actually make up that complete 180 degree angle. So angle 3 and angle 4 are also supplementary angles. But that's just dealing with the blue line. If we look at the green line also, there are a lot of things that add up to 180 degrees. So when we just look at those two lines, we see a lot of supplementary angles because angle 1 and angle 2 make the blue line, angle 2 and angle 3 make the green line, angle 3 and angle 4 make the blue line again, and then angle 1 and angle 4 make the green line. And so when we have two intersecting lines like this, we have not only the angles that are what we call adjacent to the other angles, but we also have these angles like angle 1 and angle 3. That are basically across the intersection from each other. And also angle 2 and angle 4, which are straight across this intersection from each other. And so these are two types of angles that we call vertical angles. These vertical angles are made by intersecting lines, as we can see, and they don't share a ray. If we look at angle 1 and angle 2, they share this blue ray right here, so they can't be vertical. And angle 1 and angle 4 share this green ray right here. That's the one ray that's common to both angles, so they can't be vertical. But angle 3 is made up of the yellow ones, and angle 1 is made up of the green and the purple, so they are vertical. And so there is something particularly special about vertical angles that we're going to talk about more in class tomorrow. And I'm going to ask you to write this down, not only the definition of vertical angles, so go ahead and pause the video now and write that definition down. All right, so now that you've written that definition down, if you haven't, pause the video and do that. I'm going to tell you this about vertical angles, and I want you to do two things. One, I want you to think about it and see if you can reason out why it has to be that vertical angles always have the same measure. That means angle 1 and angle 3 must be the same. Angle 2 and angle 4 must be the same. We'll talk about it in class, but I'm not going to tell you now. I want you to do this as part of your homework, is stop and think and spend a few minutes looking at this. Why must vertical angles always have the same measure? Pause the video, think about that for a little bit, and then come back when you're ready. So as we said before, vertical angles can show up all over the place. Vertical angles even show up in extreme skiing. We can see that the skis are crossed there to form two intersecting rays, or rather line segments, that form some vertical angles. The green one and the green one are vertical, and then the two yellow ones are also vertical. And so those two angles are vertical, and as we said, they have the same measure. But we can use all of these things to start solving for some angles in more complicated figures, like the ones that we have here. And so the second thing I want you to do is to look at these and see if you can reason out what each angle must be. When we have intersecting lines, like we have in 1, and we have in 2, remember that angles that are vertical, that is directly across the intersection from them, must be the same. And think about what it means for these angles to be creating these two lines, like we talked about back at this page here, and how many angles are supplementary. And then also when we have things like an angle 3, where the red line segments are a right angle, and what that means, an angle 4, where angle 1 here is a right angle, and we can show it with a little square in the corner there. So go ahead and pause the video and work on these and see what you can do, because these are examples of things called compound figures. You actually know everything it is that you need to know to find out what every angle is in these measures. So see what you can do about it. If you only get a few, that is perfectly fine, but take some time to see what you can reason through, and then when we get to class, we will talk more about those.